So what is the power factor and how does it measure up against real-world loads? Well, in your typical household, you may have incandescent light bulbs. These typically have a power factor ranging from 0.5 to 0.9 for LEDs, and for traditional incandescent bulbs, the power factor is 1. And this is because in traditional incandescent bulbs, the element itself looks a little bit like a resistor. There's no inductance, there's no capacitance, and so our power factor is generally unity. You also have a lot of heating in your household. The power factor again varies a little bit here. In a convection or oil fan, again the power factor might be close to 1, and that's because these traditional elements have highly resistive loads with very little inductance and very little capacitance. In a heat pump, however, the power factor could be as low as 0.5, but typically around 0.9. Appliances with large motors, particularly washing machines or vacuum cleaners, they present very low power factors, and this is because these motors, they use coils, and those coils look like inductors. They pull our power factor down because the proportion of real power to the total apparent power decreases. And finally, in modern households, we're starting to see an emergence of electric vehicle chargers. These electric vehicle chargers need to convert AC power to DC power, and they make use of capacitors and inductors to do so, and so they can present lower power factors. But domestic loads on the grand scheme of things are less critical for a grid than the industrial loads. When we look at the industrial loads, we have very similar things. We have a lot of induction machines, for example, but they're much larger in magnitude and they're driving much larger loads. So even though the power factor is low, it's much more critical that our grid can withstand these appliances. Similarly, commercial HVAC systems aren't too dissimilar to your aircon at home, but they're on a much larger scale, and so that low power factor is much more critical. Commercial refrigeration, similarly to HVAC, also presents a relatively low power factor. And finally, IT equipment, which is also doing a conversion from AC to DC power, can present a reasonably low power factor.